Hey students, this is your Professor Omilianchuk, and today I'm going to be talking about strategizing derivations and the working backwards strategy. This is a strategy that will help you solve every single derivation problem that you have in this class. So this is probably one of the most important lectures that I'll be giving in this whole class. So I need you to really kind of pay attention and understand what it is that I'm up to. Right, so let's talk about the working backwards strategy and how to tackle every single problem. Right, there's actually just 3 steps to it. And the first step, which is probably the most complicated and probably the most difficult, is that you need to identify the rule of inference that will be used to derive the target. Okay, so this is difficult for a couple different reasons. The first reason is that, well, you really need to know what the rules are. Okay, so if you don't know what the rules are, you won't be able to do this. Right? This is why I ask you to memorize these things and really have a good understanding of how they work. Okay, now the other thing that's hard about this is that you need to learn how to think in a forward manner. Right? You have to be able to look at your target and really understand that that's where you want to go, and think about, okay, how am I going to get that? What is going to be the rule of inference that I'm going to use on my very last line of my problem to get the target? Right? You will have the tendency to start your derivation and just look at your premises. Right, and then just see what you can do with them. And it'll be like a trial and error thing, and you'll see if you'll end up with the target. That's a very natural and understandable way to do derivations. It's the way I did them when I was learning how to do these. But it is actually a much worse way to do them. It's much more unreliable. It's much more puzzling. It's much more frustrating, and you can go wrong so easily by doing that. All right, so I encourage you, rather than looking at your premises, don't focus on those. Figure out what's going to be the rule that you use on the last line of your derivation. Okay? Because once you figure that out, once you get that figured out, then what you can do is identify the requirements of that rule. Okay, so then what's going to happen here is you think, okay, I'll have a rule of inference that allows me to write down my target. What are the requirements of that rule? And then those requirements become new subtargets. All right, and then you work to get those. All right, so that for any target that's not a premise, any target that's a sub-target or anything like that, it's not a premise, return to step 1. Okay? Obviously step 1 is the hardest. Okay? Step 1 is the most difficult one for the reasons I just gave. Okay? So, let's just kind of go through some examples of this. All right? We already kind of talked about this a little bit in the last lecture on the practice problems about what to do. All right, so let's just kind of go over some problems here. So here we have a problem, and the first thing you're going to want to do is just look at the target and analyze it. And so the question you should be asking is, okay, what type of well-formed formula is this? And the answer, of course, is a biconditional, right? So you think, okay, I need to be able to get this thing. And the first question you can ask is, all right, is there any way, does it show up in my premises anywhere in such a way that I can just extract it out of the premises? And in this case, we can. Right, the whole thing is right there in line 2. You see that it is a consequent of a conditional. All right, so what I'm going to do, okay, is that I want to, on my last line, on my very last line, eliminate this conditional. Right, and I have a rule for that. Right, I have conditional elimination, and so what I'm going to do is get the target with arrow E on the last line from line 2. All right, I'm going to have to use line 2. Okay, but if you notice that the rule, right, you also need to get the antecedent. Okay, so I have the conditional already on line 2. That's a premise, that's good. But now I need to get another piece. This rule requires two things, remember. The conditional, and then we need to have the conditional's antecedent on a separate line. Right, so CA ring DA now becomes a subtarget. That's what it's called, is a subtarget, okay? Now I'm looking at CA ring DA here, and I'm thinking, okay, where is that? Does that show up in my premises anywhere? Well, you might think so. Yeah, it's in line 2. You can use arrow elimination to get it, but you can't. You can't actually do that. And the reason why is because you can never eliminate for the antecedent, right? That's never allowed. So we have to derive CA ring DA in some other way, okay? Now, what do we do? Okay, this is kind of tricky, right? But think about it, right? CA ring DA, well, what kind of formula is that? Well, that's a disjunction, all right? And I have a rule that allows me to create disjunctions, right? It's an introduction rule, and here it is. Okay, there's the rule, and notice that the rule says if I have one part of the disjunction that is my target, so what I really ultimately want is CA ring DA, so I'm going to need part of it on a previous line. So I'm looking around here. Do I got DA anywhere in the premises? I got it right here, okay. The problem is, though, in order to get that DA, I'll have to get this whole thing. But then once I get this whole thing by itself, I'm done because that's my target. All right, so that's probably not going to work. But I do have a CA available on line 1, and notice that it is a consequent of a conditional. All right, it's a consequent of a conditional. So if I can get that CA by itself, all right, then I can use my ring introduction rule and write CA ring DA, right, and I can get that from CA. Okay, so CA is going to be P, and then CA ring DA is going to be P or Q. You see what I'm saying? All right, so next thing I'm going to do now is I'm going to try to get the CA by itself. All right, that's going to be a new task for me. I need to get that by itself, right, so that I can apply this rule of inference. Right. Now it's in a conditional I see again, and so I'm going to have to use arrow elimination in order, right, to get this CA. Okay, I got to get that. All right, so what I'm going to do then is that I'm going to get CA from line 1 using arrow elimination. But now, okay, I'm going to need the antecedent in order to do that. Okay, so now I need to get AA and not BA. All right, now AA and not BA looks a lot like line 3. You see that? It says not BA and AA. And so you might think, well, I can use, okay, I'm done. I can just use 1 and 3 to get CA. And the fact of the matter is that's not true, okay? I understand that not BA and AA is equivalent with AA and not BA, right? From a semantic perspective, I understand that. You know, you could do a truth table, prove that. I totally get that. However, recall what I said about derivations being a syntactic approach to logical entailment, right? Such that a machine could do these derivations if we programmed it in such a way. And the machine would have no idea about truth or falsity. It would just arrange the symbols the correct way. And so what we need to do is we need to arrange the symbols the correct way. Okay, so even though we know that this is semantically the same as this, we actually have to break this down, okay, and rearrange it to look like that. Okay, because that's just how derivations work. They are syntactic in nature. Okay, so anyway, it's easy to create this. All right, what I can do is I can use conjunction introduction, and I can put together AA and not BA from AA separately and not BA separately. Okay, so that's going to be one of my steps. And so then what I can do is focus in on line 3, right? And I can use conjunction elimination then, just kind of break this thing apart, right? I'll get not BA from the conjunction on line 3 by itself, right? And then I will also get AA by itself from line 3 using conjunction elimination. And notice my steps here. I kind of wrote these down, right? So here's a step here. I can get AA, right, from line 3. I can get not BA from line 3, right? And now I'm ready to go. So notice how I've done all this kind of spade work here, right? And if you're struggling with this, right, I suggest just kind of writing down your steps, right? So I figured all this stuff out before I even wrote anything down here. Okay, now I'm going to work backwards. Okay, here's how it goes. So I'm going to follow my first step. I'm going to get not BA, and then cross that one off. Right, I'm just following my instructions. Now I'm going to get AA. All right, and I'm going to follow my instructions. Okay, now I can put those two together with conjunction introduction. So I'm going to do that on line 6. Okay, and then right now I'm going to look at okay, now I can get CA. Right, with line 6 and line 1 using arrow elimination. Okay, now I can use my ring introduction rule, right, and get CA ring DA. And now I'm in a position to derive my target. And I cross that one off. Now I'm done. Okay, now I'm done. All right, and so that is how it works. Okay, the working backwards strategy is, this is a very literal, very tedious way of doing this, right? When students get good at this, logicians, they just do this all in their head, right? They can see the pathway moving backwards from the target, okay? And what we did is, the first thing we did is we identified the rule of inference we had to use on the very last line, and then we worked backwards. It's like, okay, we're gonna have to do this, and then we have to do this, and then this, and then this. And this was all figured out right here before I wrote anything down, okay? Let's do another example, okay? So here we have EA ring DA, all right? So this is kind of a complicated problem, right? But let's take a look at the target, all right? So one of the things we could do here is we notice that we have our target right there in line 2, okay? So one of the things that we could try here is we could, maybe what we could do is we could eliminate that arrow there, that AA arrow part, using arrow elimination from that's this one side of this biconditional here on line 2. All right, see that? So that's one thing we could try, right? So that might work. But then what we're gonna have to do then, in order to do that, right, we're gonna have to get AA by itself. Okay, we're gonna have to get AA by itself. Now, how are we gonna get AA? Okay, how are we gonna get AA by itself? Well, we see that AA is part of line 1. Okay, now we could use disjunction elimination. Okay, and to get AA. But if we look at the requirements of the rule of disjunction elimination, it's gonna tell us then that what we need to get is AA arrow AA, and then we'd have to get this part right here, BA and not CA arrow AA. Okay, so how are we gonna do that? That's kind of a that's not gonna work, right? There's no obvious way to get the requirements of this rule. Remember, disjunction elimination is very demanding. All right, so we're gonna have to sit and think about this a little bit. Okay. Now, I think the strategy that we tried here, while it was a dead end, did give us some clues. It wasn't a completely fruitless endeavor, right? And so if we look at disjunction elimination, right, we have a disjunction on line 1. There's P and Q. You see that? So P is going to be AA, and Q is going to be that conjunction there, BA and not CA. Now here's something that we notice in line 2, right? We kind of see that we have, right, a P arrow R formula right there in that one side of the biconditional. Okay, so you see that? AA arrow, and then the disjunction EA or DA. And that could be the P arrow R formula. And then in line 3, we have something similar. We have the Q arrow R formula. And then look at our target. our target, right, which is what we want to write down, okay, that's R, is exactly that. Look at that. That's going to be EA ring DA. Okay? So what we've done here is that we've figured out that we're going to be using disjunction elimination on our very last line. Okay? What we need to do then is get these three things. So we got the disjunction on line 1, but we got to get this piece and that piece by itself. All right? So that's what I'm going to write down. Okay? So that's what's happening. All right? So what I'm going to do on the last line is derive the target with disjunction elimination, and now I have these 3 subtargets to get. Now one of them is given to me as a premise, that's good. Okay, but now I got to get these 2 things, right? And notice that I can do that so long as I have LA on a line by itself and KA on a line by itself. Because if I can get those by itself, right, then I can do biconditional elimination. Right, so I'm going to get that AA arrow formula, right, using biconditional elimination from 2 and LA. Okay, so I'm going to need to get LA by itself, right, because biconditional elimination requires me to get 2 things, a biconditional on a line and then one side of it. Right, then I can write down the part that I want. Okay, so what I'll do then, I also need to get the other sub-target, right? This piece right here. Okay, I'm gonna get that with biconditional elimination 2 from line 3 and KA by itself, and so that's what I need to do. I need to get KA and LA by themselves, which I can get out of line 4 using conjunction elimination. All right, so I can do conjunction elimination twice again on line 4. I can get LA by itself and I can get KA by itself. Let's just do that. All right, so there they are. I got LA and KA by themselves, and I just cite line 4, and I use conjunction elimination just like my step says. Okay, next step, I'm going to write down the BA and not CA arrow EA ring DA formula from lines 3 and 6 and use biconditional elimination. Then I'm going to get the AA arrow EA ring DA from 2 and 5 biconditional elimination. And now I'm in a position to apply the last rule and use lines 1, 7, and 8 and use disjunction elimination. Okay, that is the working backward strategy in an essence. And so we had a false start with this one, but the false start did give us a clue about what to do. Right? And so this happens a lot when you're doing derivations. You're going to have false starts, right? But you just try something else, okay? And what you want to do each time when you try something else is just figure out what rule are you going to use on your last line, right? That will take care of a lot of the problems that you'll be addressing and trying to figure out in each of the derivation problems. All right, so the big question, of course, is how do we find the right rule, right? What are some ways of thinking about this, right? So that it's not so arbitrary and we kind of remove as much guesswork as possible. Well, the first step is just to kind of think about what type of formula you're dealing with. Okay, is it an atomic formula? Is it a conjunction? Is it a conditional, a disjunction, negation, or a biconditional? Because that'll narrow things down for you. All right, so you have a bunch of rules to pick from, but it's going to depend on what kind of thing you got to get. All right, and so once you kind of figure out what formula you're dealing with, you can kind of zero in on those rules that deal with that formula. Right, then you're going to determine whether you're going to use an elimination rule or an introduction rule. Those are the 2 kinds of rules that we have in this course, right? You either eliminate a connective or you introduce a connective, and there's rules that specify how to do that for each connective. Keep in mind that elimination rules just extract a subformula out of a larger formula. So try using an elimination rule first, since they tend to be simpler, right? And here's a hint that you should know. If your target is atomic, then you will use an elimination rule, right? Because remember, right, the introduction rules are always introducing a connective which means that you're going to have a compound formula every time you use an introduction rule. Right? So you need to use an elimination rule if your target is atomic. Okay? Like I just said, intro rules, they create connectives. They should be used only if they generate the main connective of your target. So don't just use them willy-nilly, right? You want to use them to get the main connective of your target. Then determine if the inputs of the rule that you want to use are available. Now you saw in that one problem that the inputs of the rule that we were trying to use weren't available, and so we had to figure out a different rule. Okay? All right, so here's the main point. You really do need to know the rules. Okay? If you don't know the rules, write them out first. Okay? Make sure you have them all before your eyes and make sure you understand them. Okay? You do have to do some process of elimination. Right? This is just part of doing logic. There's nothing wrong with this. But once you kind of narrow things down, right, it'll be easier. See if you can get your target with an elimination rule first, then try an introduction rule. And you do have to be patient, all right? And get help if you need it. I like to help students with these things. It's important that you get help, right? And learn how to do this correctly, because the working backward strategy will make your life a lot easier. You know, you have to figure out how to think forward, right? Think about your target as the destination that you want to go to, and then plan your trip to that destination accordingly, all right? All right, so here are some practice problems you can work on. I suggest you do these, you know, take about, 15-20 minutes and try to work these out, right? They do increase in difficulty, right? And there is a little answer sheet that you can consult. And again, if you have questions, shoot me an email. We can talk via Hangouts, or you can post your questions in the discussion link on Canvas. All right, so I will talk to you later.